Yes. So today we will discuss the next topic from the section 2 part of inorganic chemistry, that is chemistry of main group elements. Today, today's discussion is about the synthesis of higher boranes and borohydrides. In the previous lecture, you can watch that videos which are uploaded already present on YouTube. In this lecture, we will discuss the different methods which are used for the synthesis of higher boranes. Okay, and what are the lower boranes? Diaborane or borane is a lower borane. So see, in this we will learn that we can prepare boranes from small boranes or lower boranes. Okay, now see, for example, see, we have this B2H6. There is a diaborane. This is a diaborane which on heating undergo pyrolysis, and by using this diaborane we can prepare variety of higher borane. For example, you see borane, tetraborane 10, pentaborane 9, decaborane 14, like this. And we know uh, all about these boranes. These boranes are falls into different categories: nidoborane, arachnoborane. We know that. Okay, fine. So you see, what are the key steps how to prepare the higher boranes from lower boranes? So key steps are important to learn. First of all is dissociation of diaborane. We know B26 is the dimer of borane. So on heating, means at high temperature, it undergo into pyrolysis and undergo dissociation. And second part is what? The second step is about condensation of the BH3 fragments. This there are two steps in this. Okay. For example, let us take the preparation of higher borane. There is a tetraborane 10. What is about tetraborane 10? Means B4. What is the meaning of this 10 meaning? This meaning is this one, B4. Tetra means B. Tetra means 4. Tetraborane 10 means 10 hydrogens. Okay. What is the name of this B5H9? Pentaborane 9. Okay. What about this decaborane 14, like that? In this preparation of higher borane, the first, there are two steps, and the first example is how to prepare tetraborane 10. Though these two steps will play a very important role. You see here, first of all, diaborane undergo pyrolysis, breakage of bond, and that will convert into monomers. That is a BH3. You see, then another borane molecule will combine with this one BH3 molecule. One borane break into this two part monomer, and one of the monomer combined with a second borane molecule, diaborane molecule, and that will give you this with the loss of H2, that will give D3H7. What is the name? Triborane 7. Triborane, it is an intermediate, it do not exist. This triborane again react with BH3, another fragment of or monomer of borane, that is a BH3, and that will convert into B4H4. This is a very good and simple straightforward synthesis for the borane and a higher borane. Okay, there is a tetraborane is there, tetraborane 10. So how it is prepared? It is prepared by using diaborane, undergo dissociation from BH3 BH3. Then one BH3 react with another molecule of diaborane, and that form D3H7, loss of H2 according to the law of mass conservation, and then and multiple proportion, law of multiple proportion, and definite proportion also. All laws will act here. B3H7 will form. This B3H7 further react with another monomer of borane BH3, and that results in the formation of a very important borane, that is a higher boron, tetraboron 10. Okay, so only one is example is given. So you can, if you want to prepare B5H9, B10H14, so by using this same sequence, we can go for that. Okay. You search, all of you read from, it is given in the JDLE and many books, Atkins, Shirur Atkins, you see there. So we have taken here example of tetraboron 10. Okay, now once we have prepared the borane, then we can go for reactions of boranes and borohydride. See, in your syllabus, few important reactions are mentioned that are very important and very simple to study. Once we have the borane, higher borane, suppose consider tetraborane 10 like that, pentaborane 9, any higher borane. When such boranes, because they are gases, when reacted with the ammonia, so ammonia reacts with the boranes, and this is a very characteristic reaction takes place. What is the characteristic? One BH2 loss takes place. One BH2 group will be completely detached from the borane by the use of ammonia. You see the here. This is the mechanism. This is what the mechanism or reactions before you. You see, we have used tetraborane. So this BB bond. So four boron are there, four boron atoms, and you see there are 10 hydrogen atoms. So it is a tetraborane 10. So it is the tetraborane 10. We can say this is the tetraborane means you can write B4 H yes H10 yes B4 H10 is a tetraborane. What is the characteristic reaction this of ammonia with the borane? In this there is a cleavage of BH2 group. Means this ammonia will take out one BH2 group. Say this one. Say this one. Suppose that group is being removed or is detached from this tetraborane 10, and ammonia form bond with that this BH2 part. This is the same part. This is the same part. You see, same part. There is a formation of, so two ammonia will react. One ammonia will attack here. If you see this out of this nitrogen carry lone pair, so this attack here, we can say this bond break. Fine, yes. And in second condition, what will happen? In second condition, or we can see mechanism is not important, but what is important? What is going to out? What is uh, the product which is going to form when we such higher boranes are reacting with the ammonia? So any out of four boron, any boron can be the target. Any boron can be the target. So here, this boron will not be going to target. Why? Because there is a BB bond is retained in the product also. So we cannot target here. So this ammonia which carry lone pair will attack here on one boron. When there is a bond formation takes place, this bond shifted towards this. Fine. Yes. Okay. Means at this boron there is only one terminal hydrogen, but when this bond detach and this hydrogen become terminal, so this boron also having this two terminals. See, this one terminal and one terminal. Fine. Yes. Next point. When second ammonia attack here, the second bond break. Second bond breakage takes place. Second bond breakage takes place, and we can have, or we can say that, we can say that this one more means there is one already there is one bond BH bond terminal and one more bond is created. Means each boron would have a two terminal BH bonds here, and this BH2 group will go away with the ammonia one like this. Okay, and there will be the negative charge over all this group because of both the bond are electrons shifting towards this molecule, and therefore this boron carry positive charge, so you can write here. So this is the very simple and straightforward reaction. Remember the point. What is the point to be remembered? That is what boranes, higher boranes, when reacted with ammonia, there is a cleavage of BH2 group that goes with the ammonia. Fine. So next reaction is, first reaction is reaction of ammonia. Second reaction is about the reaction of bases. So many bases which are reported that reacts with the borane. When bases are reacted with boron, higher boranes or boron hydrides, the deprotonation means removal of proton takes place. Okay, removal of proton. There is no breakage of bond. And larger boranes play a very important. For example, B10H14 is here before you. You see B4 B10H14. So this is a base, organic base. Okay, a strong base. When this react, we know this carry the lone pair. This carry the lone pair. So B10H14 on reacting with this base, strong base, remove one proton. That proton taken by this nitrogen and that carry the positive charge, and this carry negative charge, and ultimately like this species will form. And one more hydrogen can be replaced, so it can become B10H12 2 minus, like that we can go further. Okay, so this is what the action of boron, basis on boranes. See, if you look at the structure of the product, anions, actually that is not important for us, but if you look at the structure of the product which is forming this reaction, there's an anion structure, this one, okay. So the protonation or removal of proton takes place from which carbon, or which bond, so that is BHB, bridge bond. Always bridge bond proton removal takes place. The reason is what? The reason is very simple. It is a very loose bond. Remember, the hydrogen is in between the two boron atoms. This hydrogen which is in between the two boron atoms. See this hydrogen which is in between the two boron atoms, like this. One boron on this side and one bridge hydrogen. Okay. So what will happen? Base always in search of, yes, weak proton. Yes, right. Yes or no? Yes. Base is always in search of weak proton. So this hydrogen is very far up from these two boron, because of three centers and two electrons only. So bond length is very large. When bond length is very large, means that bond can be easily undergo breakage. Remember, when bond length is more large, then the bond is weak. Remember point, okay? Okay, it's a very important point in organic chemistry. So this boron will remove this proton, and therefore remember that always the proton removal takes place from BHB bridge, okay? Not the BH bond. This bond is not going to break because this boron is having hydrogen, but this is not going to break. Why? Because it's a strong bond. Therefore, base will take this proton. See here, you can understand. You see that bridge bond, BHB bond, undergoing breakage, and there is a formation of anionic part from the higher borane, as there is a loss of H plus. You see, this H plus going with the base, and this is going with the main part, the diaborane, tetraborane or higher borane, decaborane, like that. Okay. So, what is the meaning? See here, what is the meaning? What we can say? So, boranes are called as Bronsted acid. Remember, okay. Boranes are called as Bronsted acid. Why it is like that? Boranes are called as, we can say boranes or higher boranes. Boranes are called as bronzed acid. Can you say why? The reason is very simple. Because when you react this such higher boranes, they give proton to the base, and according to the definition of the Boronstein and Lowry, any compound, any compound, according to the concept of, yes, according to the concept of acid, bronzed acid and bases. So what is the acid? Acid is, yes, acid is H plus donor, and base is any species with S except the H plus. So all higher boranes are all higher boranes are bronzed acid. Fine. All higher boranes are bronzed acid. Okay. So hope you understand, all of you. Fine. So that I wanted to show you. Fine. So see, small concept will make our small points only will make our concept strong and strong. Fine. So this is the second reaction. First is action of ammonia. Second is action of bases. Fine. Now you see, if we have the list of boranes, higher boron, B4, B5, B10. So as the number of boron increases, you can say the acidic strength is also increases. This is a bronzed acid. Okay, so B4H10 is the strongest acid compared to B4H10. B10H14 is the strongest. Okay, fine. The third reaction that can be studied about higher boranes is the Friedel-Crafts alkylation. What happened when higher boranes reacted with the condition which is available by Friedel-Crafts alkylation reaction? We know the alkylation is the what? It is the electrophilic reaction. We know that. Benzene, around Friedel-Crafts alkylation, we learn in the aromatic compounds. Generally, we have this idea in aromatic compounds. When benzene react with what? What is that? Yes, any one of you? When benzene react with methyl chloride or ethyl chloride or methyl bromide in the presence of Lewis acids such as aluminum chloride, that will undergo into alkylation, means introduction of methyl on benzene or ethyl on benzene or any alkyl group takes place. That reaction is called as electrophilic. The reason is very simple, because the alkylation supply the cation or electrophile or electron deficient species. Similarly, when we perform the Friedel-Crafts alkylation of boranes, higher boranes, by using Lewis acids such as aluminum chloride, so generally reaction will take place and it occurs where closed portion of the boron clusters. This is a very important point. So see here, this is the structure of which borane? Pentaborane. You see there are 5 boron, right? And how many hydrogen? You count the hydrogen. Can anyone tell what is this structure? Nidoborane, arachnoborane, or yes, anyone from you? Nido, nest like, arachno means spider net, and there is one more type of borane. Yes, that gives a cage-like structure, closoborane. So if you should have, once your structure is before you, you should have that idea what label should be given, what name or what label should be given to the structure. Okay, so it is what? It is a nidoborane. Remember the point. It is a nidoborane, nest-like. You see how it is nidoborane. The reason is, you see the upper side and the side views are blocked, and only from one side open. There is the down, the one side is a, from this bottom we can enter. There is a nest like, okay, nidoborane. Fine. B5, there are 5 boranes, right? B5, and how many hydrogen you count? So 5 hydrogens for 5 boranes, 5, and there are terminal 4. So B5H9, very simple. B5H9 or pentaborane 9. So when you perform the reaction of alkylation, say CH3Cl in the presence of a catalyst aluminum chloride, very famous, very well-known reaction we are learning since junior college level 11th standard, and that will give you. So you see, according to closed portion of the boron cluster. So it is the boron is a central boron. If you look at the upper view, the top view, so you see boron looks like exactly in the center of this four boron, and therefore we can say the methylation takes place. Add that carbon. Alkylation takes place. Add that carbon. Fine. Yes. And there is a loss of HCl as usual in every reaction of electrophilic substitution. Okay. So that's all. This is the reaction. So you just remember this reaction, practice this reaction, and whenever you find such questions will always be there in the exam. Okay. So you should write. And if it is MCQ, so you should write the which boron undergoing alkylation. There's a methylation, or we can say ethylation. Here methyl chloride we have used. So according to we can write. Okay, fine. Okay, so according to we can write about this. Fine. Okay, 1 minute.